All right, today we're diving into a threat briefing, but this isn't about nations or armies. This is about a war that's happening right now, all around us, even inside of us. We're talking about a microscopic arms race, and the stakes couldn't be higher.
So let me ask you something. What if germs had secret weapons? I mean, not just the ability to make you feel crummy, but a real, sophisticated, targeted arsenal.
Well, guess what? They do. We're caught in this constant invisible arms race with some of the planet's smartest pathogens, and today we're going to pull back the curtain and declassify their tactics, their weapons, everything.
Okay, so here's our game plan. First, we'll look at their offensive arsenal. Then we'll see their ultimate defense. After that, we'll dive into how some are masters of disguise. And finally, we'll talk about this evolving battlefield and where we fit in.
All right, let's jump right in with their offensive playbook. We're talking about the direct attacks. These are the bacteria that, they don't mess around. Think of them as the assassins and the demolition experts of the microbial world. So first, meet the internal saboteur, Corynebacterium diphtheria. Now, this bacterium's strategy isn't some big frontal assault. No, this is a precision strike, launched from inside our own cells. And to really get how its weapon works, you first have to understand the target.
Okay, so picture this. Inside every single one of your cells, there's a factory. It's this process called protein synthesis, and it's constantly building everything, absolutely everything the cell needs to survive. It's the most essential operation there is. Now, what if there was a weapon that could shut down that entire factory with one single surgical move?
And that's exactly what the diphtheria toxin does. First, it gets inside one of our cells. Then, it hunts down this key worker protein called EF2. Think of it as the factory foreman. And then, using a bit of chemical warfare called ADP-ribosylation, it just shuts EF2 down completely. The whole factory production line just grinds to a halt.
And the result? It's as simple as it is devastating. Total factory shutdown. The cell can't build anything it needs to live, and it dies. It's a perfect assassination.
So diphtheria is our internal saboteur, right? It works from the inside out. But not all bacteria are that subtle. Our next pathogen, Pseudomonas aeruginosa, is the complete opposite. It's all about brute force from the outside.
Pseudomonas deploys what is essentially a tissue-melting weapon. I'm not even kidding. It's a toxin called Elastase, and its whole job is to dissolve the very matrix, the scaffolding that holds our cells and tissues together, stuff like elastin and collagen. This isn't a precision strike, it's a demolition charge.
So it's clear bacteria have some serious offensive weapons. But, this is an arms race, and it goes both ways. What about their defenses? And this brings us to one of the biggest threats in modern medicine, the superbug. And this table just lays it out so clearly. On our side, we've got our heavy hitters, our best weapon, a class of powerful antibiotics called Carbapenemase. But on the other side, we have the culprit, Klebsiella pneumoniae. And it's developed this incredible, high-level resistance to our best stuff.
So, the billion-dollar question is, how? How does a tiny, single-celled organism figure out how to defeat our most advanced medical weapons?
Well, the answer is just a brilliant piece of microbial engineering. It's an enzyme called Carbapenemase, and the best way to think of it is like molecular scissors. The bacteria produces these scissors, and their only job is to seek and destroy. They find our carbapenem antibiotics and literally cut them to pieces, neutralizing them before they can even do their job.
And listen, don't think this is just some minor trick up its sleeve. For Klebsiella, producing these molecular scissors is its #1 primary defense mechanism. It's a nearly perfect counterweapon.
Okay, so we've seen offense, we've seen defense, but some of the most dangerous pathogens, they're the ones you just never see coming. They are the absolute masters of disguise.
Let me ask you this. Have you ever heard of a ghost infection? It's a chilling idea, right? An infection where doctors know something is seriously wrong, but for the life of them, they just can't find the bug. This is a real thing. It's a condition called culture-negative endocarditis, a really serious heart infection. And a common culprit is a bacterium called Coxiella burnetii. Now, the reason it's a ghost is because it's an intracellular organism. It literally hides inside our own cells. And that means it won't grow in a standard lab culture, making it basically invisible to our normal tests. A true master of stealth.
But hiding is just one form of disguise. Our next bug, Actinomyces israeli, takes it a step further. It uses active deception.
It actually creates false clues, these misleading little things called sulfur granules, to throw doctors completely off its trail.
And here's the wild part. They look exactly like little grains of sulfur, but they aren't sulfur at all. It's all a clever disguise. What they really are is these tangled, matted colonies of the bacteria all mixed up with cellular junk, all designed to look like something they're not. It's an incredible form of microbial camouflage.
And all of this brings us to our final point. The battlefield is constantly evolving. This isn't a static conflict with fixed rules. It's a dynamic, never-ending arms race.
So let's do a quick recap of the arsenal we've declassified today. We saw the precision assassination of our cellular factories by Diphtheria, the brute force tissue melting enzymes from Pseudomonas, the incredible antibiotic-destroying armor of Klebsiella, the intracellular invisibility of Coxiella, and the clever imitation and disguise used by Actinomyces.
You see, every one of these strategies is a masterpiece of evolution. It's absolutely amazing. So the final crucial question isn't just about the weapons bacteria have now, it's about what comes next. Because as these pathogens continue to evolve and upgrade their arsenals, the real question is, how will we evolve ours?